moving to part C, I've got this. The limit as x approaches 2, x minus 2 all over x squared plus x minus 6. Let's check it out. Like the previous two examples, before we can dive into L'Hopital's rule, slow down, go through that checklist. Is this simplified? And I'm kind of giving my answer away there as well. And it turns out, no, it's not simplified. X minus 2 over x squared plus x minus 6. If you ponder that denominator for a moment, you'll realize it can be factored as x minus 2 times x plus 3, which would simplify to 1 over x plus 3. And so then we can just take the limit as x approaches 2 of 1 over x plus 3, and it will equal 1/5. And now you might be thinking, why would you present something like this? I mean, these are the kinds of limits we saw, way back in chapter 2. They were in the very first set of lecture videos we did, 2.2/2.3. Right? We did this stuff. Certainly. But, now that we're learning a new rule and you're working with those in that homework and that sort of thing, it's tempting, when almost everything needs a L'Hopital's rule, to just skip right past the is it simplified or is it indeterminate and just start taking derivatives and looking at L'Hopital's rule and using it when you shouldn't. And so my encouragement here, slow down. In the homework, there are going to be problems like this, where it's not actually simplified, to keep you on your toes, because that's part of learning the rule as well, is when is it appropriate to learn the rule. Okay, so here it's not simplified, so we don't need to do anything new. Factor, boom, plug in. Okay, but I mean, what would happen if we tried to plug in? It would be 0 over 0. So even if you checked that but forgot the simplified, like, you might think it's indeterminate, it's really not. Okay, moving on. Hey, this is the second one that I presented way back at the beginning. So the limit as, hey, we've got as x approaches 0 from the right again, of x times the natural log of x. Okay, well, let's go through the checklist. This one's gonna check out, but let's do it anyway. First question, is it simplified? Well, yeah, x times natural log x. I mean, what are you gonna do with that? I mean, that's simplified for sure. Is it one of the forms? And yep, as x approaches 0, we've got 0 here. And as x approaches 0 from the right, natural log x, we talked about that already, that's headed towards negative infinity. So yes, that is in the list. 0 times infinity. Who's going to win? Is this one pulling faster? Is this one pulling faster? We're about to find out. Now, this is an interesting case, x times natural log x, because if you recall L'Hopital's rule, we need, if I just repeat the rule here, since I don't have a board to point back at, it's all about ratios, right? The ratio of the y values, that limit, is equal to the ratio of the slopes of the tangent lines. But here, we don't have a ratio. We're multiplying. So what are we going to do? The rule only applies to ratios. That's the way the rule is set up. That's the way we have to use it. Okay? So here's kind of that explanation in one sentence. To use L'Hopital's rule, we must have a ratio f of x over g of x. We must. That's what the rule says. So how are we going to do that? We got to go back and rewrite this so that it looks like a fraction. Okay. Well, how do you write that as a fraction? We've got one of two choices. We're going to bring a negative exponent in and say, all right, well, we could do this as the natural log of x divided by x to the negative 1. Hey, that would be equivalent to this, wouldn't it be? So we're not changing the expression, but we're thinking of it as a ratio. Or we could put that -1 exponent on the natural log, and do it that way. When you have that situation, it's never obvious which one to pick. So sometimes either way you pick it, when you use L'Hopital's rule, they will both work out to the answer. But most times, one way of picking it will work out just fine. The other way of picking it, whichever it is, will not get you to an answer. And I'll show you what that looks like in a little bit. So maybe just kind of like going with your instinct. Which one of these seems like, if you're just taking derivatives, like which one of it seems like, more natural or simpler derivatives? And in my history teaching this course, pretty much everybody, the majority of students say this one. I would rather take this derivative and this derivative. Here, it's not that we can't do it, but there's a chain rule on that, and this one seems like it's gonna flow. So let's try this one out first and see what happens. And if we get an answer, we're good. Okay. So here's what I've got. Just erasing some things. Okay. That's our original problem. And I'm showing you my first step there already. So what I've done, just wanted to repeat this so it's on the screen as well. And we rewrote it like this. So we're now doing the limit as x approaches 0 from the right of natural log x over x to the -1, equivalent to what we were, the original problem. But now that we have a ratio, we can perform L'Hopital's rule. So we put the L'H over the equal sign, and we think, okay, natural log x derivative, 1 over x. X to the -1 derivative, negative x to the -2. Okay, now we're going to end up plugging in the 0 again, but we don't want to do it as it looks here. We want to simplify this before I think I wrote that here. Yeah, simplify before attempting to plug in a second time. Makes sense. It's part of the checklist even. Clean it up, then try to plug in the 0. Okay, so I'm going to rewrite this denominator as a fraction. So I've got that limit as x approaches 0 from the right. 1 over x over -1 over x squared. Okay, we're going to flip and multiply. All right. We say, oh, okay, one of the x's cancels and the negative. So when we're all done simplifying, actually all we have is the limit as x approaches 0 from the right, -x. And here, oh, this is great. I'll plug in the 0, and we get an answer, 0. We got it. Cool. Okay, then thinking back, the original indeterminate form was this, right? X natural log x. So who won the tug of war? Well, clearly the 0 won the tug of war over -infinity. And so that means this x was headed towards 0 faster than this was headed to -infinity. And that's like, really, wow. X is faster than a natural log. We needed the rule to prove it, but we can kind of look back and see that, yeah, x was headed towards 0 faster than this was dropping down to -infinity. It won. Okay. Still going. Let's do a similar example where we have multiplication. Try this one out. The limit as x approaches -infinity for x squared times e to the x. A good amount of the questions in your homework do present these as a product. A good amount, have the ratio set up for you at the beginning. But a lot of them have multiple, and you got to rewrite it, you know. Okay, but let's first go through our checklist. It is simplified. Yeah, x squared e to the x, okay. Is it an indeterminate form? All right, if we plug in negative infinity, well, negative infinity squared would become positive infinity. And negative infinity going up into the exponent of e. So the exponents here are getting more and more negative, and we have talked about that situation, right? Think of it as 1 over e to the infinity, which is 1 over infinity, which our denominator is getting bigger, so that whole thing is going to 0. So that the e to the negative infinity is headed towards 0. That is one of the indeterminate forms. It's really like pretty much the same case we just had a moment ago, right? Infinity times 0, who wins? Or we had negative infinity with the natural log. Okay, so we know we're all set. Of course, this one we need to rewrite as a ratio. So there's one of two options. We could do e to the x over x to the negative 2, or we could do x squared over e to the negative x. And as you look at these, you know, it's kind of hard to tell which one we should pick, or maybe it doesn't matter, because neither, like the derivatives either way don't seem too bad. I'm going to show you guys both because I want to demonstrate, you know, what happens when you pick the wrong one, and you know, obviously the right one will lead to the answer. So the last problem, you know, it was more similar to this, right? We had natural log x over x to the negative 1. So that feels more like this style. So I'm going to start with that one, and we're going to see what happens. Okay. So there's the original problem, and we're thinking of it like e to the x over x to the negative 2. So we got our limit as x approaches negative infinity. And we're going to apply the rule. So we got the L apostrophe H over the equal sign. And now taking derivatives e to the x and taking a derivative negative 2x to the negative 3. Okay. So before we attempt to plug in again, let's simplify. Really, since here to simplify this, since I've got that negative exponent, I'm going to go ahead and just pop that thing back up in the numerator and do it like this. Okay, so got my limit. That negative 2, I'll think of it as negative 1/2, and then x to the third e to the x. Okay. Now when I attempt to plug in negative infinity to this one after the L'Hopital's rule, let's see, negative infinity to the third. Well, negative infinity to the third would be negative infinity still. Then that negative infinity multiplies by negative 1/2. So then it goes back to positive infinity. Okay, still have infinity. And when I put negative infinity here, well, that's the 0 again. Huh. So I did it, and it didn't change anything. I still have infinity times 0. So it turns out this was not the correct choice. But actually, it's not so much the correct choice that it was still indeterminate. There's more to it. It's not the correct choice because look at this, what we're looking at here, versus where we were originally. It got more complicated. This is more complicated than the original x squared e to the x. You know, the negative 1/2, well, okay, I mean, but we've got x cubed. Like, oh no, it's getting worse. So this was not the way to go. If that is more complicated than the original, don't, it's just got, if we, yeah, we don't want, this didn't give us an answer, right? It's not a good idea. Okay, instead, let's do it the other way. x approaches negative infinity. Let's do it as x squared over e to the negative x. Okay, doing the L'Hopital this time. Equal sign with my L'Hopital, L apostrophe H. Limit as x approaches negative infinity. And here I've got 2x. Okay. Here we've got a chain rule. Negative x is the inside. So derivative of e, we copy, and derivative of negative x is -1. So just a quick, super quick simplification there. 2x over negative e to the negative x. All right. Once we've simplified it, now let's think about plugging that back in. I'm actually going to keep the e to the negative x here in the denominator because when I plug in, it's going to go to positive. So I don't mind keeping it down there. Okay, let's see. Plugging in this time. So plugging into the top, 2 times negative infinity. And down here, e to the positive infinity is infinity, but then we also have this negative sign. So the denominator is going to negative infinity as well. Here we can cancel the negatives and think of it as positive infinity over negative infinity. Or excuse me, positive infinity over positive infinity. We would think, wait a second, oh no. I mean, we tried it the other way and we still don't have an answer. We still have an indeterminate form. Okay, that does not mean that we're wrong. It did get simpler than the original, right? The power on x went down. All right, we still have e to the negative x. That didn't really change. The negative sign, that's not a big deal. The power of x went down this time. This is the right choice. But what's up with this? We don't have an answer yet. You're right. It's still indeterminate, but no big deal. We can just do another L'Hopital's rule on this one. We can do it again. Oh man, okay, now it really, this really opens things up. Who knows how many L'Hopital's rules you might have to do before you get to an answer. And turns out this one, we actually only need one more L'Hopital's rule, and then we'll be able to get it. But yep, L'Hopital's rule can be used more than one time. Because, it's like we're just thinking of this as like the new problem. So, well, what if that's indeterminate? Okay, well, then do it again. Well, what if that's indeterminate? Well, then do it again. All right, so we've done the checklist here. This is simplified. We just showed it's still indeterminate. So let's apply L'Hopital's rule to this limit. So we're going to write the L apostrophe H again. Still copying limit as x approaches negative infinity. But now derivatives, well, derivative 2x is the 2. Derivative of negative e to the negative x, if you think about that chain rule, it's going to repeat, and then we're going to multiply by another negative. So certainly you can do more steps to that, to the side or whatever you need. But that derivative is going to give us positive e to the negative x. And now, plugging in negative infinity one more time, we'll still have the 2. This will go to positive infinity, so e to the positive infinity is infinity. And as our denominator increases, the whole thing heads towards 0. And if you think back, to the original question, where we had x squared e to the x. As x approached negative infinity, it was infinity times 0. Well, who won this time? Still the e won. X approached negative infinity. The e still won. We got 0 as our answer. Oh, wow. Okay, let's take a break here. We've got just one more example in the next one.